चलें जी, let us start the class. Bismillahirrahmanirrahim. Our lecture title is Zener diodes and applications. Now we come to main parameters of Zener diode. These are definitions of Zener diode parameters. The first parameter is Vz. This is the stable output, and it refers to the stable output voltage value generated by two ends of the Zener diode when the rated current passes through it. These values vary slightly with operating current and temperature, and due to the difference in manufacturing process, the voltage regulation values of the same type of Zener are not exactly the same. For example, the model number 2CW51 Zener diode has a VZ minimum of 3 volt and a VZ maximum of 3.6 volts. So VZ is the stable output voltage, and the author says that the Zener voltage will not just produce a fixed voltage, rather it will produce a range of voltages within a certain limit, that is between Vz minimum and maximum. Next parameter is Iz. This is the rated current. It indicates the current value passing through the Zener diode, not tube, through the Zener diode when the voltage regulator generates a stable voltage. Then Zz is the dynamic resistance. It is the ratio of voltage change to the current change across the Zener diode, which varies with the operating current. The Zz is the dynamic resistance, and it is the ratio of voltage change to the current change across the Zener diode, which varies with operating current. Then comes Pz, is the rated power consumption. It is determined by the allowable temperature rise of the Zener diode, and its value is the product of stable voltage Vz and maximum allowable current Izm. So the rated power is the maximum power the Zener diode can provide, and it is equal to the Vz multiplied by maximum allowable current Izm. Then comes alpha. Alpha is the temperature coefficient, and temperature coefficient is that if temperature of the Zener diode changes, its stable voltage will also change. The relative changing value of the voltage across the Zener diode caused by of 1 degree C is the temperature coefficient. So alpha is the temperature coefficient, and if temperature of the Zener diode changes, its stable voltage value will also change. And what is the temperature coefficient? The temperature coefficient is the relative changing value of voltage across Zener diode caused by 1 degree C change in the temperature, and the unit is percentage per degree C. Now we have the data sheet of commonly used diodes. In this slide, we see the data sheet of commonly used diodes. So let us first recognize the part of the data sheet, and then let us study the data sheet itself. The data sheet will always have the diode manufacturer name and the logo. So in this case, Fairchild Semiconductor is the semiconductor manufacturing company, whereas these numbers 1N4728 to 1N4764A represents the Zener diode part numbers whose data sheet is to follow. Then we have the data sheet itself. The data sheet provides the maximum, the minimum, the normal values of the parameters. So in the first part, what we see is the symbol PD, and this symbol represents power dissipation. Power dissipation for all the Zener diodes within this range. Power dissipation for all Zener diodes within these model numbers. And what is the power dissipation? The power dissipation for all the Zener diodes within these provided part numbers will be 1 watt. So our Zener diode, if we are using Zener diode within these model numbers or part numbers, then their power dissipation will be 1 watt. Then after the absolute maximum ratings, there is the electrical characteristics. The electrical characteristics first declare the device model number. For example, the first model number 1N4728A represents the Zener diode model number itself, or Zener diode part number as written or as available on the practical Zener diode. So we will have a number written on the Zener diode and this number will indicate, or it will help us to find the various parameters of the same Zener diode. These parameters will be first VZ. VZ is the Zener stable voltage. IZ is the Zener current, and then ZZ is the Zener impedance. ZZK, the impedance at knee voltage, and then IZK represents the knee current of Zener voltage, IR represents the leakage current, and VR represents the leakage voltage. So for model number 1N4728, the VZK is 3.3 volts. So 1N428A Zener diode produces a voltage of 3.3 volts, whereas the Zener current is 76 milliampere, and the Zener dynamic resistance ZZ is 10 ohms, and dynamic resistance at the minimum Zener current is 400 ohms, whereas the minimum Zener current IZK, that is the Zener knee current, is only 1 milliampere, and the leakage current is 100 microampere, and the leakage voltage is 1 volt. So we will get the values of parameters from the data sheet provided by the manufacturer.
इस डायोड का नंबर किस बेस पर रखा जाता है?
All the manufacturers, they will decide the model number for a particular Zener diode or for any component of electronics. The manufacturer will decide what will be the model number.
What about the temperature range, sir?
The temperature range is written over here. The temperature range is also defined in the data sheet provided by the manufacturer. For example, here in this data sheet, the manufacturer recommends that the temperature should be less than 50 degrees C.
Yes, sir.
And not just that the temperature should be less than degree C. The manufacturer has also said that if the temperature rises beyond 50 degrees C, then the values will derate. Okay. And if we do not follow the guidelines of the manufacturer and increase the temperature, then the manufacturer has said that the value will start to derate. The values will no longer be as provided by the data sheet. So we have to maintain the temperature, the working temperature, less than 50 degrees C. And we have learned this by studying the data sheet. So it will not come out by itself. We have to follow this.
Okay, sir.
Okay. Okay, Ji. So now we want to discuss practical diodes, equivalent circuit, and the term dynamic resistance. What is the practical diode and what is the term dynamic resistance? The practical diode always has the voltage drop of the Zener diode plus the dynamic resistance ZZ, as shown in this VI characteristics. We want to see what is ZZ, what is the dynamic resistance. If we look at the graph, on the x-axis we have the Zener voltage, and on the y-axis we have the Zener current. As usual, IZK represents the Zener diode knee current, and IZM represents the Zener diode maximum current. The region between IZK and IZM is our reverse breakdown voltage region. We have to operate the Zener diode within this region. So we take one region between delta IZ. Delta IZ is a region that we take within our provided Zener voltage breakdown region, and we observe that as current changes, there is also a change in the output voltage, that is delta VZ. So the dynamic resistance is the ratio of delta VZ divided by delta IZ, and this is equal to dynamic resistance and we will place the dynamic resistance in our practical model over here. So our practical model of the Zener diode, not only does it include the voltage drop of Vz, also it has the dynamic resistance. And what is the practical nature of the dynamic resistance is that this dynamic resistance indicates the slope, this negative slope of our Zener diode being used. तो ये जो स्लोप है इसकी वैल्यू असल में, इस स्लोप की वैल्यू होती है ये डायनामिक रेजिस्टेंस, और इसकी वैल्यू को आप यूज करेंगे in your practical Zener diode model. However, there are times when we can altogether ignore the dynamic resistance, and that takes us to the approximate model of Zener diode. Here we do not take the dynamic resistance, we do not take the slope, and we see that in this diagram, again, it is the VI characteristic. On the x-axis, we have the voltage. On the y-axis, we have the current. The Zener diode is working either in the first quadrant or in the third quadrant. When the Zener diode is working in the first quadrant, it is acting like a normal forward bias diode, and the voltage drop is of 0.7 volt. However, when we use the Zener diode in the third quadrant, when it is reverse bias, then the breakdown voltage Vz will represent the D voltage and the slope will be infinity. And we will represent such model of the Zener diode simply equal to Zener diode breakdown voltage value. As I'm going to finish this class, and we will meet in the next class, inshallah. So please everybody, all the class, all my students, please read from the textbook, and inshallah next time we will discuss a new article. Thank you very much. Assalamu alaikum.
Sir, kindly share the slides.
हाँ जी, ठीक है जी.